Yeah, good morning, everyone. Am I audible?
Yes,
Yes,
sir.
sir.
Yeah, so you are able to see the screen?
Yes, sir.
Yes, sir.
Hello? Hello, are you able to see the screen?
Yes, sir.
Yeah, so what do you see?
Yes, sir.
Simplex method? You can see the simplex method?
Yes, sir.
Yeah,
Yes, sir.
okay. So, how many participants are there? 8. Okay, doesn't matter. So, what we have is, it is just a recall session. We have almost finished, we have finished the entire syllabus. From unit 6 we have gone through the video lectures. I have circulated the video lectures and the ppts, and I've given you the task of submitting the assignment. Okay. And on unit 5 the queuing model, we have gone through the video lectures. Okay, so we'll start with the revision session on unit 1 again. The simplex method, those who have not attended the lectures earlier. So what do we do in simplex method? Simplex method is a method of solving the linear programming problems. So we have different methods, we have different approaches to solve. One is the graphical method we have seen, which is applicable only when we have two variables. So this example we have taken for three variables. The graphical method can be used only when we have two variables. The second method is an algebraic method, which is a linear method, is it? Because for example, if I have five variables, then it will take at least 20 steps. Okay, so that is n into n minus 1 steps, and it will not tell you where to stop, is it? So you have to do all the 20 steps, and then from that you can derive which is the optimal solution. Okay, but in simplex it is a progressive method. It will tell you where to stop, is it? For example, if you have three variables, okay, and two constraints, so you have to do at least what you say is two iterations. When you have two constraints, so two iterations will be required, and when you have three constraints, three iterations will be required. So it may happen that in the first iteration itself you will get the optimal solution, is it? So the simplex method tells you where to stop, is it? So maximum three iterations will be required, and it may happen that sometimes in less than three iterations you can get the optimal solution. So that is and simplex method is always a progressive method. So gradually you will see that the objective function, that is the value of z, gradually increases. In the first iteration you will have the value of z as 0. In the next iteration the value will increase from 0 to some maximum to a higher positive value, and so on. So as you go from one iteration to next, the value of z will increase in case of maximization. In case of minimization, the value of z will go on decreasing. Am I clear? So the first thing is, so we'll try to revise both the cases, maximization and minimization. So in case of maximization, what you have is the constraints are given in this form, less than or equal to. Okay. Or minimization also, you can have the constraints of this type. So you have this statement is called as an objective function, these are called as a constraints. Okay. So what you do is you first you convert this problem into a standard form. Standard form means you try to bring the constraints into equal to type. So what you need to do is you need to add the slack variables. So slack variables is just you try to balance the equation. So these are the inequalities, you try to convert these inequalities into equalities, is it? So what we have done is, so since the constraint is of less than equal to type, so you add a slack on the left hand side. So that is, so 6x1 plus 5x2 plus 3x3 plus s1 becomes equal to c26, and similarly the second equation plus s2 becomes equal to 7. Now the objective function, so you add the slack in the objective function with coefficient 0, is it? So this is your first step, is it? So convert the equations into a standard form, represent the original problem into a standard form. Now what you try to do is you try to represent into a tabular form, is it? So the table, the structure of the table is like this. The very first column is CB, is it? I'll explain it later. The first row is called as a CJ, and the second row is the base. Second row is the variables that are there in the problem. So the variables are x1, x2, x3, s1, s2. So the second row is the variable. So this forms a body matrix, is it? This is called as a body matrix. The third and fourth row, is called as a body matrix, and this part is called as an identity matrix. You can see it is the structure is similar to an identity matrix. So that is 1 0 0 1. is it so you can see x1 x2 x3 s1 s2 are the variables within the objective function, and you can see the first row is the coefficients of the variables in the objective function. So it is 30x1, 23x2, 29x3, 0s1, 0s2. These are the this is your objective function. Okay. Basis. Now what you do is you don't consider x1 x2 x3, the original variables that are given in the objective function. You don't consider those initially as the basis. What you do is whatever slack is added, you consider those slack as the basis. And the corresponding variables of those slack that are there in the objective function is considered in the CB. So the first column CB is the coefficient of the basis. So CB, coefficient of basis. So 0s1, 0s2. These are the coefficients of the basis in the objective function. Now what you do is, now you calculate zj. So represent the body matrix. So body matrix is the coefficient of the equations, the constraints. So this is the first constraint: 6x1, 5 plus 5x2 plus 3x3 plus s1 plus 0 s2 is equal to 26. Second constraint: 4x1 plus 2x2 plus 5x3 plus 0 s1 plus s2 is equal to 7. What you do is, this is, you calculate zj. It is summation of cb into aij. Cb is this column into aij. 0 into 6 plus 0 into 4. So that is zj for this x1. So zj is equal to cb into, for this column into this column will give you zj for x1, zj for x2, zj for x3, and so on. So since this value is zeros, the first column cb column is 0, all the values in the zj will be initially 0. And similarly, what you do is you try to perform multiplication of cb with b. That gives you the value of z. So in this case, initially the value of z is equal to 0. Fine. So what happens is, so this is your initial basic feasible solution. Now what you do is you perform cj minus zj. So when you perform cj minus zj, so you get 30, 30 minus 0, 23 minus 0, 29 minus 0, 0 minus 0, 0 minus 0. So this gives you the net evaluation row. And determine the maximum value. In case of maximization function, in case of maximization objective function, you consider the maximum positive value. And when you have the minimization function, you consider the least, the most negative value. So in case of minimization, you will get you just try to identify which is the most negative value. Here we are trying to find out which is the most positive value. Now that column corresponding to the most positive value is considered as the key column. So what you do is, now you divide the column b by the key column. So you mark that key column. So the key column, the variable corresponding to the key column, is called as the incoming variable or the entering variable. So x1 becomes the entering variable. Now what you do is you determine a value theta, the column theta, that is equal to b by k. So b is this 26 by 6 is equal to 13 by 3, and the next one is 7 by 4. So this is, now which one is the least positive value? The least positive value is 7 by 4. Now you don't consider the negative values. If you get the negative ratios, that negative ratio are to be ignored. So what you do is you are supposed to consider only the positive value. If you don't get any positive value, all are negative value, then the solution is unbounded. So you just write a statement, the solution is unbounded, so you just stop over there. But if you have any of the positive ratio, so consider the least positive ratio and select that row and call that row as the outgoing variable. So the variable corresponding to that outgoing selected row is called as an outgoing variable s2. So now what you do is, the intersection of the pivot row, so this row is called as a pivot row. So intersection of the pivot row and the key column is called as a pivot element. So I forgot to mark the braces. So you just add the parenthesis over here. So it is, so this 4 will be made as 1. is it? So we want to make this pivot element as 1, and the pivot column, the key column, should be made identical to the identical to the identity matrix, so that this is, if this is 1, this will be made as 0, is it? So in the next iteration, so this is your first iteration, the next iteration you make this value 4, element 4 as 1, is it? So you can see that I have divided this, s2 is replaced by x1, is it? So you can see entering x1 is the entering variable and s2 is the outgoing variable, so x1 is replacing s2. Now what you do is you just want to make this element as 1, so you divide that element with 4, entire row by 4. So this is 4 by 4 is 1, 2 by 4 is 1 by 2, 5 by 4 0, and 1 by 4, 7 by 4, 7 is divided by 4. So this element of theta will be brought into 7 by 4. Am I clear with this? Okay. So now what you do is, okay, now again calculate zj. Now you just see the coefficient cb is updated. So cb from 0 it has been updated to 30. This is nothing but the coefficient of the basis, the newly introduced basis basic variable x1. Now what you do is you calculate zj again, is it? So the steps are repeated. So 30 into 1, 30 into 1, but this is already 0, so you don't consider this. So 30 into 1, 30 into 1 by 2 is 15, 30 into 5 by 4 is 75 by 2, 30 into 0, 30 into 4, 1 by 4, it is 15 by 2. Now you try to determine, yeah, hello?
It all started with my mom.
Hello, am I audible now? Actually, it was
Yes, sir.
disconnected. Yeah, it was disconnected. So I'll just start the screen share. Yeah. So, is it fine now? So where were we? We were discussing this is how this 30 has come. 30 is updated. So this is 30 into 1. So we have discussed Z0. Is it? So Z0 now what you do is you determine Cj minus Zj. So Cj minus Zj is 30 minus 30 becomes 0. 23 minus 15 becomes 8. 29 minus 75 by 2 is 17 by 2. 0 minus 0. 0 minus 15 by 2 is minus 15 by 2. Now what you have is you try to monitor these row, is it? Now in case of maximization, unless and until you have at least one of the positive value, you can continue, is it? In case of maximization, you are looking for a positive value, and whichever is the most positive value, select that row, select that column. Okay. Now in this case, the stopping condition in case of maximization will be when all the values are less than or equal to 0, then that becomes your stopping condition. Is it fine? When all the values are less than or equal to 0, that becomes your stopping condition. And what you do is, so you check for a positive value. Unless and until you have a positive value, you continue, is it? So here you have a positive value. In case of minimization, you check for the negative values. Unless and until you have the negative values, you continue. Is it fine? Now what you do is, this is 8. So okay. So the next iteration is, now here the outgoing variable is, so you determine this is your b. Now you find out theta. So that is theta is equal to b by k. So this is your k. So 31 by 2, 31 by 2 divided by 2, it is 31 by 4. Again 7 by 4 divided by 1 by 2 is 7 by 2. Is it? Now b is equal to, so this z becomes 0 and 30 into 31 by 2 and 7 by 4 respectively. So this becomes 105 by 2. Is it fine? So that is your updated value of z. So you can see the z value increases gradually. Is it fine? So this x2 replaces which variable? X1. So it is not necessary that always slack variables will be replaced. Now in this case, x2 is replacing x1. Is it fine? So in the next iteration, you can see x1 is replaced by x2, and you can see cb from 30 it has been updated to 23. Is it fine? Now what you do is you try to make this element which was 1 by 2 and you make it as 1. So what you need to do is you need to multiply this x1 by 2. Is it? So multiply by 2. So ultimately what you get is, this was 1, so this becomes 2, this is 1 by 2, this becomes 1, this becomes 5 by 2, this is becoming 1 by 2, and this becomes 7 by 2. Is it? So you can see this is updated. Now what you do is you try to make this element 0. Is it? So in order to make this element 0, so this was value 2. So what you need to do is, with corresponding new row with this respective this value, you want to make this element 0. This was 2, so this becomes s1 minus 2x2. Is it? So you make this element 0. So this was 1 by 2. So this is, so the updated value will be minus 2, 0, minus 19 by 2, 1, minus 5 by 2, and 17 by 2. Is it? Now you calculate Zj. So Zj, this is already 0, so you multiply by 23. So this is 46, this is 23, this is 115 by 2, this is 0, this is 23 by 2. Is it? Now when you calculate Cj minus Zj, so it is minus 16, it is 30 minus 46, 23 minus 23, 0, 29 minus 115 by 2 is minus 57 by 2, 0 minus 0, 0 minus 23 by 2. Now you see, if you observe, all the values in Cj minus Z0 are less than or equal to 0. Is it? So this becomes your stopping condition. Am I clear? Are you able to hear me? One can respond.
Yes, sir.
Yeah. Okay. So this is your stopping condition. Okay. So are you able to understand what we are going through? Is it? So 16. So this is your stopping condition. So you are supposed to stop. Is it? So in the second iteration, so maximum 2 constraints were there. So maximum there will be 2 iterations. So this is the maximum iterations we have reached, and you can see also the stopping condition is achieved. All the values in the Cj minus Z0 are either less than or equal to 0. So you stop over here. Is it? Now you can just get the value of Z. So value of Z is obtained by multiplying CB by B. Is it 0 into 17 by 2 and 23 into 7 by 2? So that is, this is your maximum value of Z. Is it? So you can just conclude your statement by saying that the maximum value of Z is equal to 161 by 2. And what is the variables? The variables are x1 is equal to 0, x2 is equal to 23. Sorry, x2 value is 7 by 2 and x3 is 0. Is it? So whatever is in the basis, so this is your and s1 is equal to, sorry, s1 is equal to 17 by 2, but s1 coefficient is 0 in objective function, so it holds, it does not contribute in the objective function. Even though it has a value 17 by 2 s1, it does not contribute in the objective function because its coefficient is 0. So this is 23 into 7 by 2. So x2 value is 7 by 2. Other two variables x1 x2 is 0. Is it fine? So you have the final value of the objective function as 161 by 2. So that is your final value of the objective function, and you can conclude it over here. Is it? So in case of minimization function, what you need to do, you just try to determine the value of Cj minus Z0. It should be the most negative value, and the stopping condition will be all values should be greater than or equal to 0. Is it fine? When you get all the values 0 or positive, then that becomes your stopping condition in case of minimization. Is it fine? Okay. Now the second type of problem is where you have all where you have some of the constraints as greater than equal to or equal to type. Is it? So in that case, what you try to do is you try to introduce the artificial variables. Is it? So artificial variables are nothing but what you do is, so when that is added because you have the negative slack. Is it? And negative slack cannot be used, only you require the positive values. Is it? So what you do is you try just refer the book. In that case, it is explained. I have not made the slide. Is it? For that I did not get time to prepare the problems. Is it? So what you need to do is you just try to add the artificial variable. Is it? You don't consider the negative slack. Instead of negative slack, you just add the artificial variable, and the coefficient of that artificial variable in the uh, objective function will be m. Is it? In case of maximization, it will be minus m. In case of minimization, it will be plus m. Is it? So why it is plus m? Because in case of minimization, plus m contributes the maximum value and the value will increase of the objective function, and in case of maximization, minus m will decrease the value of the objective function. So m value is the largest value, is it? Some maximum positive value or maximum negative value, plus m and minus m in case of minimization and maximization respectively, is it? So you can just go through the book, and if you have any doubt you can revert me. You try to solve the problems, is it? Okay, so we have gone through the revision. Do you have any problems related to maximization or minimization problem or artificial variable? If you have tried to solve it, you can just type it in the chat box. Nimisha, कोई डाउट है? Big M method, if you want I can just we can discuss.
Yes sir, BM method एक बार explain कर दो ना.
Big M method में क्या होता है कि when you have now I have not just a moment. ठीक है. Now when you have constraints like this, when you have we have discussed the constraints of less than equal to type, is it? But when you have constraints of greater than equal
Yes.
to type or equal to type, is it? So then what you do is, in this case, in this two type, this is one and this is second, is it? In these two types, so you have a negative slack, you don't have a slack, is it? But what you do is you introduce an artificial variable, is it? So because of this you have a negative slack, but you don't have slacks in this kind of equation. So whenever it is already given in the standard form, you just add an artificial variable, is it? And for each artificial variable, so let's say you have one constraint of this type, so you have plus s1, but here in this is your second constraint of greater than equal to type. So let's say you have an objective, you have a problem where you have three constraints. One constraint is of less than equal to type, so in this case you will have plus s1. This is a second constraint of greater than equal to type. Here you will have minus s1 s2, but for minus s2 you add plus a1, is it? You add plus a1, and here you don't have the slacks, neither positive neither negative, so here you add plus a2. Am I clear? So you have what will be there in the basis. In the basis here you have, for this corresponding constraint, you have s1 in the basis, here you have a1 in the basis, here you have a2 in the basis. Am I clear? So when you construct the basis, you have s1 a1 a2, so you have one slack and you have two artificial variables, and then you try to solve it, and the objective function will have let's say x1 x2 is the objective function, x1 plus x2 is less than equal to, or maximize x1 s2 is the objective function, maximize x1 plus x2 is the objective function. So 1 x1 plus 1 x2 plus 0 s1 plus 0 s2, so s2 is there because it is a negative slack, plus 0 s2 plus ma1 for this one, and plus ma2 for this one, is it? So sorry, not plus, it will be minus, since if it is maximization it will be minus a1 minus a2. Am I clear? Minus ma1 minus ma2, is it? And then you can solve it, is it? And build the body matrix, and then you can solve it. So gradually artificial variable, logically artificial variable should go out of the system first. So outgoing variable should be artificial variables initially, and then slack variables. Am I clear? So as many constraints, that many iterations will be there, is it? You try to solve it, it is simple. Agar nahi samajh mein aaya, to you just revert back. I'll just take a Zoom meeting again on the Big M method.
Yes sir.
I did not get time to solve that problem. It is you just see that almost 45 minutes it took me to properly, or you can, if you see this, it took me 45 minutes to properly note down or create notes on this. Okay, so unless and until you practice, you will not get clear idea, is it? Or you'll not be able to cope up with this. In any case, in the exam you will get 3 hours to solve, but still you will have less time, is it? You have observed in mid-sem exam, you did not get time to solve all the problems. So some of the students have not solved for 30 marks. Is it fine? Okay. So Big M method, any doubt? ठीक है. In case of maximization, again you have to follow the same thing. In case of maximization, try to check for the positive value, most positive value. In case of minimization, try to check for the least negative value or the most negative value. Not sorry, least negative value. It is most negative value in case of minimization. ठीक है. So only observe you have whether you get whether you have the greater than or equal to constraint, greater than equal to or equal to type of constraint. In these both these equations you will get both these equations you will get the artificial variables in this case also, but in this
Sir?
case also. हाँ बोलो.
सर जैसे मैक्सिमाइजेशन में आउटगोइंग वेरिएबल लीस्ट पॉजिटिव सिलेक्ट करते हैं, मिनिमाइजेशन में क्या सिलेक्ट करते हैं?
लीस्ट पॉजिटिव वैल्यू. बी इज
दोनों में?
नेवर नेगेटिव. हाँ, बी में बी तुम्हारा हमेशा जो थीटा जो तुम्हारा रहेगा वो लीस्ट पॉजिटिव वैल्यू ही रहेगा.
ठीक है सर.
ठीक है. But B, the Cj minus Zj rho is most negative, most positive value in case of maximization, and most negative value in case of minimization. It is only for Cj minus
Okay,
Z.
sir.
In case of theta,
Okay,
it should be always least positive value. Whether it is
Okay, sir.
maximization or minimization, it should be always least positive value.
Okay, sir.
ठीक है. So any doubt?
हाँ सर.
Should I take
No, sir.
on transportation in the next Zoom? You want a big M method in the next Zoom, or you want a transportation method in, or whatever is the problem, you just revert me quickly wherever you have doubts. You just tell me. I don't think you require a Zoom meeting on Unit 2. Unit 2 is just Ford Fulkerson and so on, the network concepts, CPM, PERT, and it is simple. ठीक है. So you can refer the notes and you can easily recall.
सर रिवीजन ऑन यूनिट 3.
यूनिट 3 का ये है ना, इन्वेंट्री मॉडल लेना है तो ले सकते हैं. इफ यू वांट आई विल टेक इट.
सर प्रोबेबिलिस्टिक मॉडल और उसका देखो मतलब ले सकते हैं.
प्रोबेबिलिस्टिक मॉडल और हाँ ठीक है.
हाँ मतलब मॉडल 3 एंड प्रोबेबिलिस्टिक मॉडल.
ठीक है, आई विल टेक इट. सो इट इज प्रोबेबली मॉडल 3 एंड प्रोबेबिलिस्टिक मॉडल ना. ठीक है. So we have last 10 minutes remaining. So I'll just note it down. It is you require on queuing model. Sorry, inventory model, model 3 and probabilistic model. Okay. Anything else? And transportation do you require? Assignment is simple. Anyone you requires assignment and transportation? जल्दी बोलो. Assignment और transportation लेना है नहीं लेना है?
सर ट्रांसपोर्टेशन लो ना सिर्फ.
ठीक है. सो नेक्स्ट मीटिंग हम ट्रांसपोर्टेशन लेते हैं. बिग एम लेना है. बिग एम यू रेफर. हाँ, बिग एम एक रेफर करो तुम. अगर नहीं समझ में आया तो यू कैन रिवर्ट मी. सो इन द नेक्स्ट जूम सेशन आई विल टेक ट्रांसपोर्टेशन.
ओके सर.
ऑन थर्सडे.
ओके सर.
ठीक है. ऑन थर्सडे वी विल हैव अ जूम सेशन ऑन
sir.
थर्सडे ऑन ट्रांसपोर्टेशन. ठीक है. आई विल ट्राई टू कवर द यूवी मेथड. ठीक है. टेस्ट फॉर ऑप्टिमलिटी. ठीक है.
Yes,
सो
sir.
बाय द टाइम यू जस्ट गो थ्रू द
sir.
बिग एम मेथड. अगर नहीं समझ में आता तो यू कैन रिवर्ट मी. So on Friday we'll take a Zoom session on big M method. On Saturday a Zoom session, or on Monday a Zoom session on, or rather on Saturday a Zoom session on this thing, inventory model, probabilistic and queuing model 3. ठीक है. So next Zoom session
Yes,
will be
sir.
on Thursday on transportation. ठीक है. So you can revert me by evening today. So can I expect Nimisha, anyone? So you just go
Yes,
through
sir.
the big M method by today evening. नहीं समझ में आता है तो ही बताओ. अगर समझ में आ रहा है तो फिर will not waste time. ठीक है.
Yes, sir.
चलेगा? Everyone, is it fine?
Yes, sir.
So
Yes,
transportation in the next Zoom. Yeah. Thank you.
Thank
So thank you. You can
Yes, sir.
you can leave the meeting. Thank you.